I'm Anil Kumar. Welcome to my series on sharing some important concepts to solve questions. The question here is, given a triangle with vertices A minus 2 minus 3, B minus 1 0 and C 7 6, find the value of K so that the point 0K lies inside or on the triangle ABC. You can always pause the video, answer the question, and then look into my suggestions. Now, let's try to sketch a triangle, rough sketch. A is minus 2, minus 3. So let's say, okay, we'll sketch it here. So, minus 2, minus 3 will be somewhere on this side. Minus 1 and 0 will be on, correct, somewhere here, and then 7 6 will be somewhere there, right? So let me sketch this as kind of like this. Okay, let's connect. So it's an approximate diagram. So we have this point A, which is minus 2 minus 3. We have a point here B, which is minus 1 0, and C, which is 7 6. We are given a point 0K. So let's call this point up somewhere here. 0 means it is on this axis, right? Somewhere on this axis. So that is the point which we are given. So it can go all along from this to this side, right? That's what it is. Now when you actually sketch the diagram, you can see that the y-intercepts of these two lines will help us figure out the answer, correct? So that is one way of doing it. So what we can do is we can actually find the equation of these lines and then find the solution using the y-intercepts of those two lines. So that becomes a solution definitely. But see what happens if I change this number to something else. Can I find a general solution or a general way of doing it? So we'll talk about a concept to solve such questions, and we will use this criteria as our check to test the results. You understand my concept, correct? I could have just placed this value of y-intercept for both these lines, BC and AC, to give you the answer for this particular question. However, the situation may be different. This point could be not 0 but something else, okay? So in that case, you will need a method to do, right? So if I write this point as half, for example, then how will you do it, correct? So in this particular video, we will understand a general method of doing it. Now the method here is that if I'm saying that 0K, a point, let's call this point as P, right? A point P, let's call this point as P, is inside a triangle. It means really what? It means that if I'm looking from one side, let's say BC, then the point P and A are on the same side. And when I'm looking from the side AC, then P and point B is on the same side of the line AC, right? And if I'm looking from the line AB, then point P and C are on the same side of AB, correct? So the concept here is that position of 2 points with reference to a line. That is the concept. So we are looking for 2 points, one the vertex and the point itself, to be on the same side of the opposite to vertex side of the triangle. Does it make sense to you? Correct? So this is the concept we are going to use. Now, to show what is the possible value of P being on the same side of these sides of the triangle, what are we going to do? We need to find equation of each line, correct? So let's find equation of line AB first. So what is equation of line AB? To find the equation of line AB, we need to first find the slope. right? So slope AB, A to B will be 0 minus 3, which becomes plus 3, since that is minus 1 minus 2, minus 1 plus 2. That becomes the slope. And so we get the slope as that is just 3, right? So we get y equals to 3x plus b. To get the value of b, I will use the point minus 1 and 0. So 0 equals to minus 3 plus b. So 3 equals to b. And therefore, the equation of the line AB, let me say equation of the line AB will be what? Will be y equals to 3x plus 3. Perfect. Now similarly, let us find the equation of the line. Since we are moving vertical, we can actually find all the three, and then we'll figure out the all possible values. A to C. Okay. So to find equation of the line AC, we'll again look for the slope AC. Slope A to say 6 minus 3, which makes it plus 3. 7 minus 2 makes it this, which is 9 over 9 or 1. So we get the equation as, we can use either one of these points. Now this time we can use this formula, y minus y1, let it be 6, equals to m times x minus x1, which is 7. So we could write this equation as, bringing all to the right side, 0 equals to x minus y minus 7 plus 6, which is 0 equals to x minus y minus 1. Clear? Let's write this also in standard form. We get 3x minus y plus 3 equals to 0. Okay. Now let's find the equation of the third line, which is BC for us. So equation of the line BC. Slope m for B to C is 6 minus 0, which is 6, over 7 minus 1, which is 8. So it is 3 over 4. Equation of the line will be, let's use this point, y minus 0 is y equals to slope 3 over 4, x minus x value, which is plus 1. Clear? So we'll cross multiply, 4y equals to 3x plus 3, and then the equation 0 equals to 3x minus 4y plus 3. So we get three equations. Correct? So this is line AC, this is line AB, and this is our line B to C. Now we'll consider the position of the point P. It should be on the same side, right? So same side. Now let's consider these two as limiting factors. So we'll consider point P to be same side of BC, for example, right? So we'll say P and A. So we say P and A on same side of line BC, okay? So in that case, what is the condition? That means if it is on the same side of BC, then this is our line BC. We'll plug in the point value, which is 0k, right? Point is 0k. So if I write 0 for x and k for y, I get this as minus 4k plus 3 times coordinates of this point is minus 2 and minus 3. So if I put minus 2 and minus 3 here, so we get minus 2 times this as this different thing, minus 2 times 3 as minus 6, minus 3 makes it plus 12 and plus 3. So that becomes the product. What we're trying to do here is we'll place the point on the equation. Now, if points are on the same side, then they will either have both negative values or both positive values. That means they're not on the line. If it is equal to 0, point is on the line. But if it is positive, it is above it. If it is negative, it is below it. Now, if you are looking for same sides, then both should be, in this case, negative for us, right? So we'll see what this value is. Now, this value should be greater than 0 for us, greater than equal to, since the point can be on the line also, right? So that becomes the equation to be solved. So from here, what do we get? From here, we get minus 4k plus 3 times 15 minus 6, right? So we get 6 plus 3 is 9. That should be greater than equal to 0. Now you can divide by 9, so that goes off. And here, we get minus 4k plus 3 to be greater than equal to 0. Taking 3 on this side, minus 4k should be greater than equal to minus 3. Dividing by minus 4 gives k. When you divide by minus, the sign changes. So k should be less than 3 over 4, correct? So you get one condition here. Is that clear to you? Now, let us work on the point P and B and the line which is A to C. So A to C is this particular line, right? So let's work on this line and the points P and B, right? So for that, P to B, what do we get? So if I substitute P in my equation, which is 0k, this is 0, that is minus k minus 1 times, now if I substitute minus 1 and 0, so I get minus 1, right? So, sorry, this is y, correct? Yeah, this is minus y minus 1, okay, that's correct. So, if I substitute minus 1, 0, we get minus 1, minus 1. That should be greater than equal to 0, correct? Now, if you have confusion on this concept, we have a set of videos on position to points with reference to a line. I'd like you to look into those videos, okay? Now, that gives us minus k minus 1 times minus 2, greater than equal to 0. So when you multiply by 2, everything becomes positive. That's what I'm trying to say. So we get 2k plus 2 greater than equal to 0. Taking to the right side, we get 2k greater than equal to minus 2, or k is greater than equal to minus 1. So we get the interval of k, that k should be greater than minus 1 and less than 3 by 4, right? So that is our solution. So we are saying k should be greater than, this is greater than, right? So greater than equal to minus 1, but less than equal to 3 by 4, correct? So that becomes the answer for us. Okay, if this was a simple question based on multiple choice questions, you could have done by finding the y-intercepts, right? Now, as you can see from here, if you look into these two lines AC, so AC, what is the y-intercept? The y-intercept for AC is basically minus 1, right? So this is a y-intercept, correct? We know this is minus 1 AC. And what is the y-intercept for line B to C? For line B to C, the y-intercept is 3 over 4. This is the equation, correct? So if I write down this as y equals to 3 over 4x plus 3 over 4, the y-intercept is 3 over 4. Do you see that? So the result is exactly what we were thinking about. That is, it will be between the y-intercepts. Now, if the question was based on 0k or 0 on the other side, based on x-intercepts and y-intercepts, this is a much simpler question. However, if the point is generally in between, then the concept which you have seen in this particular video helps to solve. So I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.